Welcome, everybody. My name is Turk.
And I'm Ionuț.
Today we are going to talk about our future, about green coding. So I have an important question. Who doesn't like green coding? And be honest. Or like if you don't like it, just raise your hands. Nice, nobody. Oh, you don't like it, oh nice.
Just
so,
a joke.
yeah, it's not only about sustainability, but it's more than that, because we also have something like improving developer productivity. We are giving some tips for that. We are going into depth in build caching, in Spring Boot caching, all kind of ways to improve your happiness and also the build. And sustainability. So that's pretty nice. The most important question is, what's in it for me? What's in it for you? We are going to tell you more about the 8 principles of green software engineering. If you code, what do you need to remember if you're going to code? We are also going on tips on architect level, and maybe you can tell something about it.
Yeah, and then I will go inside into the JVM. We did a bunch of experiments to reveal the energy consumptions based on some patterns. Yeah,
Nice.
It will be interesting, I guess.
And we have some Java code, actually, with IntelliJ. So hang on there. And also some front-end code. So a lot to discuss, I think. But we have an hour. So.
Yeah.
So, but first, what was my reason? Was it also your reason, that video? Or? Yeah, a little bit, yeah. So the next video, the credits to the European Union. I need to say it because I show you a YouTube video. And it's about my reason why you should think about green coding, because we can make an impact when coding on our work. So let's start. It's a 2-minute video, by the way, so we are...
This is you. This is our homes, our cities, our lives and livelihoods. And this is climate change. It's here. It's happening right now. People sometimes wonder, what will happen in Europe if we do nothing, if we let global warming continue? Each year, an additional 50 million people will be exposed to high wildfire danger. Heat waves will cause 90,000 more deaths every year than now. Over 2 million more people will be flooded in coastal areas and river floodplains, while annual flood damages will rise to 300 billion euros. There will be major shifts in ecological domains throughout Europe, with alpine tundra seriously contracting and almost disappearing in the Pyrenees. Droughts and water shortages will impact southern regions even more than they do now, affecting farming, crop yield, energy production, and public water supply. What will happen if we act? If we limit global warming to well below 2 degrees, how will people, the economy, and ecosystems in Europe benefit? 2/3 of the increase in people exposed to high wildfire danger would be avoided. 2/3 of the increase in deaths from heat waves would be avoided. The impacts of coastal and river flooding would be more than halved, and stress on ecosystems and habitats would be considerably lower. The drop in water resources availability and drought losses in southern regions would be halved. And if we also adapt to climate change, we can reduce impacts even further. Adaptation can have long-lasting benefits for our people, economy, and our ecosystems. Our study illuminates the importance of the European Green Deal, putting climate action at the heart of our long-term strategy, and why Europe is committed to be climate neutral by 2050.
So that was my personal...
That was it, right?
Yeah, that was a talk. No,
Thanks.
no, yeah, thank you. It's more than that. We want to make an impact because I believe in innovation also. So I'm not perfect. I'm driving a car and that kind of things. But I think we can make an impact in our work to just think about some simple principles when you build some systems from the scratch of on. So, hi, my name is Turk. I'm a developer. I'm a speaker also, as you know, community lead and a blogger. And we also have a Twitter. It would be nice if you can post some messages from us. It would be nice. And who are you?
Yes, I work for Raiffeisen Bank International in Vienna. I do a lot of architectural part, but also a lot of coding, actually. Yeah. I also have this title of security champion in the company because working in the bank, you do a lot of security things, but in addition to that, speaking and blogging.
Nice. And working, by the way, for Adesso. So they also have an office. I needed to say that. Yeah, sharing is caring. If you want the slides already, it's there. And GitHub, we also share them later on, so you can check the code and that kind of things. So yeah, like if you look to the aviation industry, it's like 2%. It's polluting with emissions. But in computer, in the IT, it's also like somewhere between 2%. So from building till the actually running on your device is also 2% more or less. So we can also make an impact there because, yeah, we're running data centers everywhere, we are coding. So on every layer, I think we can do something. It can be very simple and we will be very practical, right? That's most the difference of other talks, green talks, that we are more practical, I think. First, the philosophy. Yeah, if you say like, hey, I'm doing this for sustainability, it's already an argument. So from that mindset, yeah, we try to be greener within boundaries, of course. There are 8 principles, and the 8 principles are you need to be aware of carbon. Like number 1, you need to be aware of, hey, my code is costing energy. Also, you need to think about solar driven or like the wind. Your hardware is also can be, yeah, you can also save some there. You can go to the cloud, serverless. We tell you more about that. You can also think about less connections to my to another system in our code. That's even better. So we will going into that later about caching, for example, Spring Boot caching. We can also run it at certain times, like batch processing, like job runner, that you have a batch processing, and you can maybe later on do it on a certain time when there is a lot of energy and it doesn't cost you a lot of energy and money at the end. And we need to monitor it. So that are the 8 principles you need to be a little bit aware of also when creating an architecture. So we are going to begin with the architecture. And the most thing that will take an advantage is, yeah, choose a language. Like Java is an eco-friendly language, and it's even better than Python. Who's programming Python here? All Java developers? Java developers? Other? Other? Okay, yeah, I know that.
Me too.
So Java is the perfect choice to be more aware for sustainability. And also, if you compare it to other, like it's a little bit on the level like C# and Erlang is way too high, and F#, and Java is doing pretty good there. So Java is the right choice for your application. Also, what is very important, throw away what you don't need. Like I'm using Kafka, for example, but then you need to use it for a good reason. If you like, I'm working at a bank, and then you have a lot of transactions, millions. That's big data, and then it's a choice to use Kafka. But if you're only doing batch processing or a small application, and you think it's cool to use Kafka, don't use it. It adds extra complexity, and it's not needed. So throw away the things you don't need, and yeah, don't make it over complex. And if possible, also, no microservice. Who's writing microservice here? More, right? Yeah. Yeah, we had that problem also in our work. Like, hey, we have a lot of applications, a lot of repositories everywhere, and that there's a microservice there. Yeah, who is owning that one? Yeah, we are only owning that one. So yeah, we can just bundle it in one and then make a big monolith because we are only consuming that. So you need also to think about functionality where it belongs. So don't make microservice by default. Have a good reason for that because it's extra connections again. And if you use microservices, yeah, the most important is optimize your database. Mostly the things between your database and your application, there you gain the most. And yeah, of course, you need to understand some things, optimize your network traffic, and even think about caching on HTTP protocol. It was even said in Amsterdam when I was at the Amsterdam Jug. Yeah, we are caching on HTTP level. So on that level, it's also possible to cache some things. But yeah, now the interesting question, code. Who is using Maven? Who is using Maven 3.9 or higher? Okay. Who is using caching? Nobody. Wow, that's the first time that it hits me. So yeah, with Maven caching, you can cache your artifacts. So if you're running your build, like with a Maven clean package or something, then you need to do the testing and that kind of things. And if you have a lot of modules in your project, then you can save a lot of precious time, like from seconds to minutes, and maybe sometimes also an hour. So you don't need to wait for your build to complete if you don't change anything in your project or in your module in this time. It knows like, hey, in module A, I changed something, so I only built that one. So that's a huge advantage if you use Maven caching from 3.9, I thought, to implement that. So that's tip 1. And what do you need to do with that? We need to adjust our pom.xml. So what we need to do, yeah, people said like on Twitter, like use the latest version. This is the latest version. There is an issue in it, but this is the latest latest version. There's also 1.0.0. You can also use it, but yeah, best use the latest version. And then, yeah, for Gradle, who's using Gradle, by the way? A few. So if you want to have caching in Gradle, it's also possible. You just add this to your settings file. And then some code. I want to show some code. So it's perfect, right? Is the dark theme good? Yeah? Yeah, okay, because the white was like so much coming on to you. So if I am going to build this one, so for example, I do, maybe better do it not here. Because it's always an issue, like a clean package from your IDE. And then it's going to build. So I didn't do anything. This is just a default project with some modules in it, like a greeter, and I got it from the internet, Eugene P, and that's a great starter. And yeah, you can see it takes 8 seconds. So this is just a single project, or like a simple project. And if you go here and you do something like this and add the extension with 1.1.0 and you do it again, you will see, yeah, it's already there because it knows like, hey, I didn't change something. Okay, the build is passing like after 1 second. But you can imagine if you have a big project, you have a build time of 20 minutes, you can save really a lot because mostly we are waiting to the build to pass or that kind of things, and you don't want it because it's a useless waste of time, I think. So if you do it another time, it's even quicker. So it's even less than a second. So yeah, that's tip number 1 now. So going further. Yeah, it's also on this, if you want to read it, I create a blog about it, and yeah, you can implement it yourself. You can also implement it in your pipeline, but you need to do some more actions there. And then, going serverless. I like the GIF. Everybody likes kitties and cats. And so, yeah, going serverless is also a great way to save some energy and also the bill at the end, because you're only consuming what you're producing or processing. And there you also save a lot of time. Also on the JVM, you can already save some credits there. Auto-scaling, we can also think about auto-scaling by Kubernetes. Who's using Kubernetes here? Okay, that's 25%. And or you can use something like Cloud Foundry. We are using at the Rabobank, we're using Cloud Foundry, and you can also auto-scale, and you can, like at night, you only run 1 instance, and at 12 o'clock in the midday, then you have 3 instances or 4 or something, like it's auto-scaling on themselves. And then it's up to you.
It's obvious like this. Yeah, thanks. So, thanks, Ko. I will try to, what's my purpose? We did a bunch of experiments with different flavors of JVMs. The main point was to understand how much energy those JVMs consumes under different loads. Yeah? So, therefore, we covered all of the main JVMs. And what we did and we finalized was the Linux x86-64 chipset from Intel measurements with all of those JVMs, including Prime from Azul, including the native image with profiling guarding optimizations, the flavor. We also covered the OpenJ9, the Eclipse OpenJ9, the former IBM. How we did that? On Linux, I used Ubuntu, but on Linux there are plenty of tools for that. One of these is PowerStat. PowerStat, what it does, it reads with a sample, with a frequency, the CPU counter, some CPU energy counters, using the REPL interface. You have there the REPL interface, which stands for running average power limit. This is particular to Intel chipset. You don't have that, for example, on on Mac M1 or M2. Yeah, so it's particular to Intel. Therefore, it's a bit handy to grab the power consumption. The only caveat with that is the total power consumption for your machine. So if you have a process or in your machine, you cannot isolate how much energy consumed that process, because the CPU itself, on the CPU can run concurrently other processes. Therefore, the main interest, and we were extra care to create a very isolated environment during the measurements, which means, for example, run only the JVM as less user space processes, because then you measure everything. The second caveat with REPL, and this is not also for REPL from Intel, yeah, this is also valid for Power Metrics. If you are using Mac OS, you have Power Metrics there. It cannot give you the full energy consumption, including, for example, the I/O part. It gives you only the CPU. Therefore, what you measure, it's relevant for the CPU, but of course the full box can, for example, if you have an intensive I/O operation, you can consume more and so on and so forth. You got the idea. But still, I mean, we try to understand, at least from the CPU power consumption, what's happening in there. This is the architecture of REPL on Intel chipset, as you see. What is of an importance if you try to use the same, or if you are interested in doing the same things, the Intel itself do not support, so before Intel 13th generation, now it's the 14th generation, yeah? The chipset, it was included also the DRAM part, which means on the older Intel CPUs, you can also include the memory power consumption, which is bound to the DRAM. But starting with the 13th generation and 14 and so on, the DRAM was not part. They deprecated this feature, so it's only for the CPU exclusively. So this is another caveat. I have two types of measurements, two types of applications that we measured. Yeah? One type is I try to measure some web-based or RESTful APIs, web-based applications, one with Spring and the other one with Quarkus, but my message is don't compare Spring with Quarkus. This is not my intention. It's very hard to compare Spring with Quarkus energy consumption-wise, because of course the libraries are different. Nevertheless, we try to be a bit more comprehensive to take some custom off-the-shelf applications, like for example one in Spring and one with Quarkus. I will show you a bit later on. And this was the full architecture of my load test system. So what I used, I had two machines. On one machine, you see it here on the test client machine, I just installed the load generator. In my case, I use VRK. Have you heard about VRK as a load generator? Are you using JMeter? Okay, maybe approach me. You should stop using JMeter, yeah? Yes, seriously. Anyway, it's on the same side with these load generators. VRK, you code the load test, and then between the test client machine and the system under test machine, on the system under test machine, there was the JVM itself with the process itself, and then the load test was triggered during 2 hours of duration. This is also an important point. If you try to measure a JVM without load itself, you don't measure anything. You need to have a process which is measured, and that process should have a consistent and significant load. Therefore, you see there PS. I measured also some hardware stats. For example, I was sure that the CPU is going up and I consume memory during the full life cycle of the test. Because otherwise, if you just start a JVM, an application, and you don't do anything, you don't get anything out of this. The energy consumption will be probably some idle threads running inside. Therefore, you need to really bombard your JVM as comprehensive as possible with all the endpoints possible for a longer duration to measure the energy. That's the idea. And this is what we did. Now I will jump inside. So everything what I'm saying to you, it's written, I've published this morning. So it's a fresh new publication. Yeah? And I'm trying to explain a few cases, not all, just the important points, because you have the full article. You can go into details if you are interested in. And all the code that we wrote, it's public on GitHub, as I've said. So don't worry, you have all the resources possible. Good, so I think at least I want to zoom in a bit, or is it good enough? It's okay now, okay, good. So, this is the first application. You know Spring Pet Clinic application, everybody knows it, yeah? I just took it, and then I started it, and I created the load test scenario, 2 hours duration, and within those 2 hours, I actually hit different endpoints from Spring Boot application, endpoints that creates, Spring Pet Clinic creates owners, pets, visit, and queries those informations. And what I've did with Power Metrics or Power Stat, depending on the OS, I measured the overall energy consumption. And here is you see here, bottom is the energy watt hour. So I summed up all of the energy consumed into this plot. By the way, because it's about energy consumption, shorter it's better, of course, because it consumes less energy. And here I included all the JVMs I was mentioned about. You have them color, the colors in the legend from Oracle, the native image. By the way, are you using native image? Just a few. The ones that are using, do you use it with PGO, Profile Guided Optimizations? No idea. That's fine. So the thing is, with native image, you can see the default one. So if you just compile it natively, it consumes less energy, which makes sense because in principle, less energy with native image, you build it up front, and then during the runtime, you have less memory footprint, probably less CPU footprint, and so on and so forth. Native image consumes a bit less. All the others, not so much differences, I would say, but, the energy consumption is just one side of your coin. Because the problem is, imagine you have a car, right? You have a car which it's very eco-friendly, consumes very less, but the thing is, you want to drive 500 kilometers, and that car, which is very eco-friendly, takes you 2 days. Would you choose this car, which takes 2 days, or a diesel or a benzene one, which you go there faster in 6 hours? That's the analogy with a real-life situation. The energy consumption is just one side of the coin, but the performance is the other part of the coin, yeah? Because you also need to understand, okay, this consumes less energy, but at which cost, yeah? How much performance I've got inside, yeah? Because, of course, as I said, you can be very eco-friendly. If you want to be very eco-friendly, just walk these 500 kilometers, yeah? You'll be the most eco-friendly versus a car. But it matters how fast you are in some situations. Therefore, yeah, I want to show you the throughput. Basically, the throughput is the performance, yeah? And you see, even if native image consume less energy, it's not in long-running situations. In particular, in this case, what I'm saying, by the way, don't make it general valid, yeah? It's just these use cases. It's less energy, but of course also less throughput, because the problem with native image, you need to enable PGO, profile-guarded optimizations, for long-running applications. And if you do that, of course, it's the best one in this graph, yeah? The throughput is better. This is a throughput, so longer the bar chart is, better it is. You get more benefits, but getting back to this plot, you see this is the native image with PGO. It's not the most eco-friendly one. So that's the thing. You need to look at this energy consumption from what you pay, but what you get out of it. Yeah. For me, what you get is how much latency. These are not latency based. It's only throughput based. But still, if I'm interested in throughput, maybe I'll do something. Yeah. And that's one part of the story, yeah? What I have a lot of graphs in this article, because all of them were generated out of my measurements. And yes, so this was one idea. The next application was, because Cole and I talked, okay, if we include just Spring, maybe it's good, but let's add Quarkus as well. Do you use Quarkus? Okay, so this is for you. But again, don't compare Quarkus with Spring, because these are two different applications. For Quarkus, we took this simple application, which is on here is a quick start from them. We just took it as granted and we just started it, and that was it. Yeah? And then the same principle. Of course, it's based on the latest Quarkus. I guess this is the latest Quarkus version, or probably a very new one. And with 2 hours of load testing, we try to measure again the energy consumption. And for this particular application, I'm using only 1 gigabyte of heap memory. And yes, this is the energy consumption. These are the stats for the energy consumption. As you can see here, Azul Prime was the most efficient one, because it consumed less energy. Eh? These bars, if they are shorter, because it's energy consumption, it's better. Yeah? Again, you can see fluctuations. It's probably very hard to anticipate which one is better, yeah? You just need to measure it. But if you go inside, so this is, remember this end-to-end energy consumption, the bars, and then you see here the throughput, it's not like this. So the energy consumption doesn't correlate at all with the throughput. And I will tell you later on, there is no relationship at all. Yeah? Because here you see the Azul Prime was the most efficient in terms of energy, but yeah, it's probably a bit less in terms of throughput. Yeah? On the other side, GraalVM Oracle, for example, consumed one of the most energies, but in terms of throughput, it was one of the best ones. So it's very complex, and it's not predictable at all. Yeah, measuring energy consumption versus how much you pay for the energy, how much performance you get. And yes, we also, so these were the 2 use cases for the bigger application, more or less, but we also had some sort of small coding patterns, like memory access patterns. You know, when you access memory, for example, they are mainly to ways. You can access it sequential based on some predictable pattern, or you can access it collocated, so you can access memory within a page, for example, from the OS within 4K. This is usually how it is, and because you access one element and the other one is collocated, accessing the next one later on, it might be a chance to be in the cache already, because the way CPU houses the memory, it's in terms of cache line, and so on and so forth. And the last one is striding, which means, and the last one is you access randomly objects from the heap without any predictable pattern, and they are not collocated at all. Yeah? So these are the main paths of accessing the memory. And this is what we got. For example, random page, I'm accessing elements randomly within one page. So because they are collocated, there might be a potential cache hit for the other one which was collocated. This is the random page, and this is the linear. Linear is accessing linear is the most optimal one. But you see here, look on these trends. The trends between these three use cases are not very much, different. Of course, across the JVMs are, but not like these trends, you see? These trends are probably one order of magnitude in difference. For example, random heap with linear. Which means if you try to understand, if you try to measure small snippets of code, you are never relevant enough in terms of energy consumption. So if you measure small snippets of codes, like for example, I'm trying to measure this loop cycle, I'm trying to declare this property local and not globally. Yeah? It's very, very irrelevant from the energy consumption perspective, because the JVM itself has a much bigger footprint than these little tiny things, yeah? Because what I'm saying, I know on the market there are some plugins which measures energy, which tells you how you should write your code to be more eco-friendly, yeah? I tend to disagree with almost all the rules, because nothing is precisely, we don't have any guarantee. The only thing is you need to measure on a higher scale, and this is what matters. Yeah? Small code improvements do not matter. You cannot, it's not like in performance. In performance, you can measure one tiny little instruction, and then you know how many cycles you get. In energy consumptions, that is not like that. We don't have precise tools in the industry. Our hardware do not offer us precise tools to measure the instruction level, how much energy you consume. Yeah, therefore, I also did other type of experiments, like logging patterns, yeah? So I try to log with different patterns, like, for example, I'll try to present you this one, and then I'll move. If you try to log, yeah, you can have multiple patterns, like, for example, we call guarded parameterized, guarded unparameterized, and I will show you what I mean. Yeah. So with Lambda, I'm using this Lambda logger, I'm using this Lambda, and this is the Lambda that I'm using for logger. Guarded parameterized, it's called guarded because I have this guard at the end, and I check if the log is enabled, and then I log it again. This is anyway nonsense most of the times, because the .log does the same behind. Yeah? Guarded unparameterized is guarded, but it's not parameterized. It's just a string concatenation. This is parameterized because you have these curly brackets and the indexes, and so on and so forth. So these are all the situations. And as you can see again, yeah, you have the energy consumption trends for each of these cases. So they are probably around the same, not big differences, in some cases, yes. But as you see here, the other ones, which is the throughput itself, are likely more different than the energy trends, yeah. Again, to me, it looks like, for example, measuring energy consumption for small code patterns it's probably a waste of time in my opinion. You need to have a bit of broader. I think you can save the energy on a higher level, on the architectural level, as Ko mentioned before. Like, for example, think of serverless as pay-as-you-go model if it makes sense. Do it monolith instead of distributed if it makes sense. Things like that. This saves you energy. But just mold tiny little pieces of the code, it's very hard. So all in all, I have other use cases here, but I won't go through all of them because the idea is pretty much the same. What I want to also emphasize you, so we covered a lot of scenarios here. What I want to emphasize you, so including virtual threads, if you are interested in, we also measure the virtual threads. What I want to emphasize you is what I showed was only the runtime energy consumption, but also the build time energy consumption. It's important. Therefore, of course, it's not unexpected that building something natively takes more energy consumption because it takes the process of build it's longer versus in comparison with non-native one. And if I have to summarize something, based on, if I have to summarize based on the data that I've gathered and based on the measurements, you can have a higher energy consumption, better throughput, higher energy consumption, or better performance, higher energy consumptions correlated with lower performance, lower energy consumption, better throughput, lower energy consumption, lower throughput. There is no relationship. If you hear from somebody that is more performant, it consumes lower and less energy always, this is not really what practice tells us. So my idea, and maybe here I have to move further, we covered all of these things, it's very hard to anticipate. It's very hard to anticipate which JVM is the most efficient one. Of course, there are some trends. I don't want to make conclusions out of it because it will be a bit not very accurate. What we try to do is try to understand what's the relationship and if we can recommend something. But as it is, there is no recommendation, basically. You need to measure it for your use case because we have an option how to measure it. Of course, it's not fully accurate, but it is something, and I think that's it. Don't trust anybody, just measure out your things. That's my message to you. And now I'm passing over to Ko for other interesting Java coding.
Cool. Thanks, Ionuț. So, we talked about, you already said, it's better to spend your research and that kind of things on your GVM than on your code. But there is coding available that checks your code, like Sonar API. And it's a little piece of the pudding, but it is something what you can do. It's not perfect, but it's something. So they have a lot of rules. You can, if you use SonarQube, you can already. You want to say about something? Okay, yes.
You read my mind. So these are the rules that I said before. Take them with precautions. I personally don't think that if you follow all of this, you'll have a more eco-friendly JVM. You have to measure it. Sometimes these are very little, tiny pieces that might or might not help you. That's the idea.
Yeah, indeed. But the little things can actually be nice. But measure the GVM. That's a little bit the conclusion, right? That's you can get the best out of it if you improve it. If you look at sustainability, performance, and that kind of things, you can also use it in your pipeline. So what is also interesting, and then you're coming to the architecture level, less cost to other systems is more sustainable. And it's also more, you gain more performance with it if you look at that. So then you look at caching, but from another perspective, from your code. So there is a Spring Boot starter cache, and you can use Spring Boot caching. And what this does is, like, if you're doing a lot of calls to a system, like you are working at a bank, and we're doing a lot of calls to one of servers to get some cost of something, and it's always the same, almost. except it changes once in a few times a year. Then you can think about caching, like, hey, I want to have a new call like every first day of the month or something, or you can use it every hour or something, and that kind of mechanisms are also there. So if you have something like this and you can cache it, because it saves a lot of the time, performance, and it's also sustainable. So they are tied together. Yeah, how does it work? You have an annotation called cacheable, and cacheable is it's caching based on a key. So in this case, it's a number, and if that number is above 10, then it's going to cache it, and otherwise it don't. So that can be very handy. I'm just checking if I have the code here. Do I have it here? Spring caching. So there's also something called cacheable, but there's also something like cache evict. So you can say like, hey, at the scheduled time, so you can use something like an add scheduled, and you can give it a cron or something. It has a cron, and it can default like this, and you can just say like, I'm using, by the way, GitHub Copilot, it's perfect. It saves me a lot of time, but this is creating already a cron tab for you. It's 00, so yeah, I don't know exactly what this, every midnight, so this is Copilot also. So that's pretty useful. If you have no idea what it's, what does it mean, then you have something like, like Copilot. So it wasn't pretend to do this, but yeah. But the cache effect that works perfectly. But you can also, with cacheable, you can also think about like, hey, I have an addresses cache, I have a directory cache, but you can also think about a distributed caching, like Hazelcast or something, and that kind of things. It's less sustainable because in memory by default is better, of course, because you're consuming less energy if you instead of calling other servers. So that's better. So you can use something like caffeine or that kind of things. Jcache, I thought. But you can also think like, for sometimes I want to have distributed caching. So you have something like a cache manager, and that cache manager can like the cache manager which you created, or you have another cache manager for Hazelcast. So yeah, with this you are like, that's pretty handy. So next one. So this was tip number 2. We also have some front-end code. It's also pretty interesting. If you go to website Carbon, it's a website, and you can just measure your front-end. So it measures if you're sustainable or not. So do you have a website URL what is nice maybe?
Vox Bucharest?
Vox Bucharest? Do I have it already in my Vox Bucharest? This one? This one? Yeah. So we can measure it. I hope it's good. I have no idea. There's exciting things about live demoing and that kind of things. So yeah, it's like cleaner than 59% of all the websites globally. So you can already see like this is the average here. So you're doing better than the most of the websites. So what does it mean? You try to minimize HTML, compromise images, videos, and that kind of things. And that's that you can do for your own website. And say to your boss, hey, we need to be more clever in our website because it's taking ages before I open the page because you're loading a lot of videos or photos and you don't want it. It needs to be like kilobytes. It will be better or even less. So. Then the next, like, there's also something websites like this, and if like 98% is better, then you know, like, hey, we need to do something about this because, if you look at performance, probably it isn't good, and also if you look at sustainability, it's also not good. So, you can test it right away. There's also a library called CO2.js. And it's an open source JavaScript library that you can measure from bytes to emissions. So you can measure your node server, for example. You have a server, and on the back end you have the bytes, and you know which bytes you're going to send to the client. So you already know, like, hey, how many emissions you are going to produce, and that's based on a model. And that model is or on you're calling a system, or you have the full data center model, so they counted the efforts, and then you can calculate it based on a model. So that's also not perfect, but it's something. I also have made an article about it. Your front end is killing, and you can do something about it. Also, all kind of things, a little bit commercializing, sorry. But go to the Green Web Foundation to find more about these kind of things. It's a pretty nice website that tells you more about CO2.js and even more. So in the improvements, check your images, videos, content, downloads, try to compromise them. Or compress them, sorry, minify them, avoid certain things, and use compressed data. So, what to remember after this talk? So, eco-friendly architecture, that's the most important thing. Think about your architecture. If you're calling systems, like you're calling system B, but you don't need it, don't do it. Or build it like the functionality in your own application. So everyone is saying like a monolith is like, it's very bad, but isn't bad, because if the functionality all relays on your team, why is it bad? So microservice is not the magic word. So it is nice if you work with multiple teams, but if you don't have that, just try to minimize it there. And choose the appropriate GVM.
Yeah, whatever that might be, because it's really hard to anticipate what might be the appropriate one and to find a sweet spot between eco-friendly and performance, being that throughput or latency. So you always have to measure it.
Yeah.
That's
the magical word, right? Measure it.
Yeah.
And you can also make small enhancements on Spring Boot caching. There's already something you can do. It's pretty nice. The build caching, what I show you, I hope you can right away use it, because it can save you time on your build, and that's pretty nice, I think. It's every day saving you a minute or something. It's still a minute, or maybe it's an hour or something. That's also possible. I've seen that. So measure everything. I think that's the most important conclusion, I think, takeaway.
Yeah, measure everything and don't trust anybody.
Yeah. So there are also books that's telling you more about green software, how you should program and that kind of things. The architecture one is the most valuable one, I think, but there are also other things. But I promise, join VDBUH if you want to talk more about OpenJDK, about Java. There is a real community, and it's pretty active in the Netherlands already. Within the Amsterdam JUG, and join then on the Slack. So if you have questions or problems with the GDK or something, you can just ask them there, like, hey, my GVM has something, or I have a Java question, or maybe I need a speaker for my conference or for my company. It's also possible. And we have stickers. So this one is from the Utrecht JUG. This is the VDBUH one, Java, and we have our own sticker, I'm going green. So I hope you can just take it, they are here. And we want to thank you and try to go green, I would say. And if you have questions, join Ionuț and me. And if you want to contribute, do you want to add something? Maybe?
No, you have said it perfectly. Yeah. Thank you.
Yeah, so thank you very much. And hope to see you, take some stickers. So thanks.